Good evening, Titans. This is Mr. Simpson, and tonight we'll be learning how to graph quadratic functions in the form ax squared plus bx plus c. So open your WSQ journal to lesson 8.3, and we shall begin. One of the first things up here talks about maximum values and minimum values. A maximum value for a quadratic function will occur when the parabola opens down. And for the parabola to open down, remember the a has to be less than 0. So this point that sits up here is the maximum point, and the ordered pair xy, the y value, is your maximum value. For a minimum value, the graph must open up. And for the graph to open up, remember, our a must be greater than 0. And if a is greater than 0 and it opens up, and this is the minimum point, then in that ordered pair, the y value of that ordered pair would be considered the minimum value for that graph. Now, if we take a look at the core concept here for graphing f of x equals ax squared plus bx plus c, again, this first bullet just talks about that if a is greater than 0, the graph will open up, and if a is less than 0, the graph will open down. Also, a point that can help us graph is the y-intercept. Now remember, the y-intercept is where the graph crosses the y-axis. And in this case, the value of c in the quadratic function is always your y-intercept right there. The x-coordinate of the vertex. Now this is what we're going to be using a lot today. So right here, the x-coordinate of my vertex, when the equation is given to us in the form ax squared plus bx plus c, the x value is always found by taking the opposite of b divided by 2 times the value of a. And that will always equal the x value of our vertex, which would also then be the line, the vertical line here for our axis of symmetry. All right? So, again, this part right here, the most important part, is that negative b over 2a is the x value of our vertex. And if we take this and we substitute that x value into our original function, then the y value we get out would be then our vertex of x followed by our y. So let's take a look at an example here. So they ask us to find the axis of symmetry and then ask us to find the vertex. So in example 1 here, we want to identify our a and b first. So our a is equal to 2 and our b is equal to 8. And so remember, the x-intercept is found by taking the negative b over 2 times a. So our b is 8, so a negative of 8 divided by 2 times a, well in this case a is 2. So now I get negative 8 divided by 4 is a negative 2, and that is the x value of our vertex. So x equals a negative 2 is the axis of symmetry. Now they want us to find the vertex. So remember, to find the vertex we have to take this value and we have to substitute it into x into our function. So we have to find f of negative 2. So we take 2 times negative 2 squared plus 8 times negative 2 minus 1. So powers first, negative 2 squared is 4, and we have 2 times 4 is 8, plus 8 times negative 2 is a negative 16 minus 1. So 8 plus negative 16 would be a negative 9, minus 1 would equal a negative 10. So our vertex for this parabola would be negative 2, comma, negative 10. And this would represent a minimum point because our A was greater than 1. All right, so now we'll do example 2. So let me erase this. And in example 2, again, our A is equal to 1, our B is equal to 6. So again, to find our axis of symmetry, which is also our x value of our vertex, we take a negative B over 2 times A. So that'd be a negative 6 over 2 times 1. Would be a negative 6 divided by 2 would be x equals a negative 3. And that's the axis of symmetry. Now again, to find our vertex, we're going to take this negative 3 and we're going to substitute it into our original. So g of a negative 3 would equal negative 3 squared plus 6 times negative 3 plus 5. Negative 3 squared would be a positive 9 plus 6 times negative 3 is a negative 18 plus 5. And now we get 9 plus negative 18 is a negative 9 plus 5 would equal a negative 4. So our vertex in this case would be the ordered pair negative 3, comma, negative 4. All right, so those are the steps we use to find the axis of symmetry using our negative b over 2a, and then using that value to substitute it back into the original function to find our vertex.